Hello guys, today we are going to discuss the estimation of cholesterol by Zaks method. So here cholesterol, as we know, it's a derived lipid of the class 1 and class 2 lipids, that is the simple and the complex lipids, where those are going to get hydroxide and the formation of the cholesterol is going to take place. This cholesterol is going to have the structure like this with the 27 carbon and double bond between 5 and 6 carbon here, and hydroxyl group at third position here, and it is going to have CPPP ring, that is cyclopentano perhydrophenanthrene ring, that is nothing but 3 cyclohexane rings, that is ABC. This one is A, this one will be B, this one will be C, and the cyclopentane ring is D, this one. Here it is the cyclohexane. So here this is the structure. Now here further we are going to discuss the principle. In this we are going to collect the cholesterol, which is protein free sample. If you are going to take any sample which should be protein free, where we are going to treat this sample with anhydrous ferric chloride acetic acid reagent, and further then it is treated with concentrated sulfuric acid. Now here when we are going to treat cholesterol with acidic in the acidic medium, as it is acetic acid is having acidic medium, the dehydration is going to takes place, leading to the formation of the cholesterol 3,5-diene. Further, with the help of the ferric chloride, and the oxidation is going to takes place, where the same compound is going to turn to bis cholesterol 3,5-diene, where the addition of the sulfuric acid or the reaction with the sulfuric acid is going to lead to the sulfonation process, where the disulfonic acid derivatives are going to happen. So where these disulfonic acid derivatives are going to give pinkish red color in the ending reaction. So this pinkish red color is measured calorimetrically, that is the absorbance will be measured calorimetrically at 560 nanometer. In some procedures it is 520, 540 also. So here we are following 560 nanometers under a green filter. With the help of the green filter, we are going to measure the absorbance of this pinkish red color for this cholesterol estimation by Zaks method. Now here further, this reaction has been employed by Zaks, who is the inventor of this method, to estimate the cholesterol in an unknown food sample. So here we can use any sample, but here any sample like even the blood of the human also, but here we are using the food sample as we are doing this in the lab. Now here completely this particular method is the chemical method. Here you can see the use of the ferric chloride, acetic acid, concentrated sulfuric acid, all this we are using. Here we are not using any kind of the enzymes or any other biochemicals. So here it is completely a chemical reaction, where we are going to measure the presence of the cholesterol within the sample. Now reagents required are, stock reagent is the standard one, where we are going to use 100 mg of cholesterol, which will be dissolved and made up to 100 ml with glacial acetic acid. Concentration will be 1 milligram per ml, whereas the same will be used to prepare the working standard, where about 2-4 ml of the stock solutions was made, and where this 4 ml will be made up to 100 ml with ferric chloride acetic acid reagent. This will be the 40 microgram per ml. The concentration will be made to 40 microgram per ml, because as we are taking 4 ml from the stock, each ml is having 1 microgram, where we are going to dilute it by 100 times. The 4 ml will be diluted to the 100 times, so each ml will be having the 40 micrograms. Here it's a typo error, this will be mcg, that is the micrograms. Now further, how to prepare ferric chloride reagent. Now here ferric chloride reagent will be prepared by dissolving FeCl3. If we are going to take 1 gram of ferric chloride in 10 ml of the glacial acetic acid, then it is the 10%. Then followed by diluting ferric chloride solution in sulphuric acid, apolar sulphuric acid, with dilution factor of the 10. So whatever the volume we have taken here for the 10%, by dissolving ferric chloride in glacial acetic acid, that has to be diluted 10 times with the H2SO4. Now here, for example, here we have made the combination of ferric chloride and the glacial acetic acid for 10 ml. Then here it has to be made up to the 100 ml. So this is the complete reagent where all the chemicals has been poured. And apart from that, we can also take the chemicals separately, where ferric chloride glacial acetic acid can be prepared for, either can be prepared for 0.05% or 0.5% also, and we can have the separate sulphuric acid and glacial acetic acid. And now here these are the chemicals how we are going to prepare. I will tell, this will be little confusion when you are going to get into the other slides, but I will make it very clear that how you have to use it. Now preparation of unknown or food sample. Now here either you can take unknown sample or any food sample. So here you are taking the food sample for the cholesterol estimation. Here you are going to take 20 ml of the food sample and 40 ml of chloroform was added and centrifuged. The supernatant was used for estimation. Now you are going to use, when you are going to use chloroform is the one of the deproteinizing agent. So here you are going to use the food sample and 40 ml of the chloroform. After some time, when you are going to centrifuge, whatever the proteins present in the food sample will get collected at the bottom. So whatever the supernatant will be present, that can be used. Or the unknown amount of the given cholesterol is diluted to 100 ml with ferric chloride acetic acid reagent. Either you can take the ready-made unknown amount of the cholesterol, or you can prepare this food sample kind. So this is going to be the preparation of the unknown food sample. Now in the next slide we are discussing the procedure. This procedure we will discuss directly in the protocol. Now here, when you are going to see the first column, second, third, fourth, fifth, sixth, and the last is the absorbance. In the first column we are observing the test tubes which we have collected to take the standard solution in the sample. That is, in the first there will be the blank test tube, next will be the S1, S2, S3, S4, S5. So all these 5 test tubes will be going to have the standard solution of the cholesterol which we have taken, and further will be the T1 and T2. So here this T1 and T2 again will be having the duplicates of D1 and D2 also. Here T1 and T2 test tubes and D1 and D2 test tubes is going to have unknown sample in that, where we are going to identify or estimate the cholesterol. So here in the third column we are going to mention the amount of the cholesterol we have taken in the standard solution. That is at 0.5 at the first S1 test tube it will be 20, 40, 60, 80 and the 100. Now here after this we are going to make up all these test tubes volumes to 5 ml with the help of the 0.5% ferric chloride. Now here when you are going to consider this test tube is going to get 4.5 ml of the ferric chloride. Here we are going to add 4, here we are going to add 3.5, here we are going to add 3, here we are going to add 2.5 ml of the ferric chloride. Here we are going to add 4.5 ml of the ferric chloride both for T1 test tube and D1 test tube, and here also we are going to add 4 ml of the ferric chloride for both T2 test tube and D2 test tubes. Now here after this we are going to mix the complete reagent and the samples what we have taken, so in their respective test tubes. After some time, like after doing vortex or mixing of this particular reagent within the sample and the standard solutions of cholesterol, we are going to add 3 ml of concentrated sulfuric acid to each test tube. Now here we are going to add concentrated sulfuric acid from the sides of the test tubes, so it should not make a sudden reaction and cause any harm, that is it can break the test tube itself. So here we are going to add slowly the 3 ml of the concentrated sulfuric acid from the sides of the test tube, and then we are going to slowly mix the whatever the reagents, and we are going to add this 3 ml to all the test tubes. So here till here each test tube should have the 8 ml of the total volume of the all the chemicals and the reagents and the sample we have taken. Now here for the blank we are going to add directly the 5 ml of the ferric chloride and 3 ml of the sulfuric acid. So we are going to add the complete volumes which has been recommended here to the blank. So here blank doesn't have any standard solution or the sample. It was going to have only the ferric chloride reagent and the concentrated sulfuric acid. Now after that we are going to mix the contents well, and we are going to keep the contents at standby at room temperature for 15 minutes so that the reaction can complete on its own. After that we are going to estimate for the absorbance at 560 nanometer with green filter. Now here in this procedure slide you can see that filters typical wavelengths, that is for red filter it should be 630 to 750 nanometer, for green filter it will be 510 to 570 nanometer, and for blue filter it will be 360 to 480 nanometer. So here if you are going to take green filter, with the help of the green filter you are going to measure the absorbance between 510 to 570. As we are measuring at 560 nanometers, green filter is the appropriate one which we are going to use to measure this red or pinkish red complex which is formed in the reaction after the reaction. Now here after the absorbance measured, this blank is set to be 0, and further after that we have got the absorbance at 0.05, 0.10, 0.15, 0.18, 0.25, and the samples what we got is the absorbance of 0.10 and 0.15. Now here as we got the same absorbance value, we have removed the D1 and D2 samples to make the table clear. So here we have taken this particular samples T1 and T2 where it is the same in the D1 and D2 samples also. So here we got 0.10 as the absorbance value and 0.15 as the absorbance value. So this is what the protocol, and this is what the same the procedure which we do. So it has been put in the protocol. It is good to discuss on the protocol to understand at the good site. Now here when it comes to standard graph plot, here we are going to prepare the graph as per the values, that is the microgram per ml of the cholesterol and the absorbance what we got at 560 nanometer. So these values are dependent on these values. it is nothing but that absorbance will be taken on the y-axis. Always y-axis is dependent on x-axis, where the x-axis is the independent, where the amount or the concentration of the cholesterol has been taken. So when these values has been subjected, these values has shown this particular curve. Now in this, when you are going to consider that the values has shown 0.5 for 20 micrograms, 1.10 for 40 micrograms as it is here, 0.15 for 60, 0.18 for 80, 0.25 for 100. Now here when you are going to see the sample values, if you are going to consider 0.10, that will be here on the y-axis, the absorbance value. Here if you are going to consider, this is going to take this particular graph line and it is going to fall perpendicular till here. So it is 40 micrograms of the cholesterol is present in this particular sample of 0.5 ml. You have to remember the volume also. Now here the sample of the 1 ml, it is giving the 0.15 as the absorbance value, where the y-axis is showing this particular graph line, which is going to fall perpendicular to this 60 micrograms of the cholesterol. So here this is how the graph will be plotted, and it will be red. I have avoided the use of the perpendiculars because it has been exactly fallen into the readings itself, so it is very easy to explain and understand also. Now here next we are going to calculate the result. Under this we are going to consider the volumes. Remember, volumes are very important here. In the graph we are going to omitting because to just get the exact concentration which has been seen within this particular samples which we have taken. But while calculating we are going to take the volume, because we are calculating we are doing the reaction as per the deciliters or the volume. Now here when you are going to consider 0.5 ml of the given unknown solution of cholesterol, which is containing 40 micrograms of cholesterol. Therefore 100 ml of the given solution contains 40 divided by 0.5 into 100. Now here it is nothing but 40 into 100 divided by 0.5 is going to give 8000 microgram. When you are going to consider 1 milligram is equal to 1000 microgram. So here when you are going to consider 8000 micrograms, it is equal to 8 milligrams of the cholesterol. So here there is the presence of 8 milligrams of cholesterol in 100 ml of the sample of the T1. Here it is the sample of T1, so it is 0.5 ml. T1 is 0.5 ml. In the same manner, if you are going to calculate for 1 ml of the given unknown solution that we have denoted or mentioned or marked for T2 sample, so here we are going to see 60 micrograms of cholesterol. Therefore here we are going to see 100 ml of given solution contains 60 divided by 1 into 100. So here there will be 6000 micrograms of the cholesterol will be present, which is corresponding to 6 milligrams of the cholesterol. Now here the food samples which we have collected in the given unknown solutions are showing to be as the 8 milligrams of the cholesterol in them for 1 ml and 6 milligrams of cholesterol in the 1 ml. Now coming to the little discussion part, here the total cholesterol levels less than 200 milligrams per deciliter are considered desirable for adults. Now here when you are going to see or get the results of the cholesterol, when you are going to give the blood sample for the cholesterol estimation, here this is what you have to be very careful with, that if it is lesser than 200 milligrams per deciliter, then it is considered to be as the desirable for adults. Readings between 200 and 239 milligrams per deciliter is considered borderline high. So it should not go 240 and above. A reading of 240 milligram per deciliter and above is considered as high. Now here, when you are going to consider this particular chart or the discussion or the warning lines, these warning lines are very important for those who are having the any what do you call cholesterol defects, that is having high amount of the cholesterol. Then this particular warning has to be taken to be as the serious, because the food items what we are going to consume each and every day are going to have the high lipid concentrations. These high lipid concentrations is going to lead to increase in the cholesterol amount. Because of that, the risk of that particular defects may get higher. So the intake of the cholesterol has to be monitored. If there is any mentioned high risk of the cholesterol by the doctor, then the intake of the cholesterol has to be monitored under the 200 milligrams per day. 200 milligrams per day, not irregular food habits. So here the diet will be mentioned by the physician or the doctor or the specialist who is taking care of the patient. So according to that, the intake of the food or the diet has to be taken with the medicine has been recommended. So here cholesterol is the one of the main component of the body, but if it is going to get higher than what is required, then it is going to lead to the severe disastrous consequences in the medical field for that particular individual. So here we should have the tab for the intake of the lipids or the oils, which is going to give rise to the cholesterol derivatives. So here this is regarding the cholesterol. So I hope I have been clear with the Zaks method. If there is any doubt or any question regarding any point in the explanation, please come back to me in the comment section and ask for the doubts so that I can clear you on this spot. Thank you very much. Thank you for tuning the big book.